In 2022, the release of Python 3.11 introduced a new piece of syntax, and to me, the syntax changes are always the most interesting when looking over the release notes. What problems were people having that couldn't be solved with the available syntax? Or does it allow more powerful, concise, or safer ways to write code? Regardless, you should be aware of the changes before encountering it in someone else's code and being caught off guard. So come with me as I learn the finer points of slideshow animations as I take you on a deep dive into ExceptStar.
ExceptStar and friends are brought to you by PEP654. See site and documentation for more details. Here is the syntax. We can call something in a try block, but instead of our standard except, we use ExceptStar. You cannot mix ExceptStar and the normal except in a try block. You'll learn that very quickly yourself, as Python would raise a syntax error upon parsing your code. Likewise, you'll get a syntax error if you try to return, break, or continue from within an ExceptStar block. That is to say, you cannot jump out or leave the block early, unlike a typical except. It is technically parsed as two tokens, so you could put a space between the except and the star. Don't do that. Now the main feature. Unlike your typical try except statement, which will catch one exception and run the first matching except block bound, ExceptStar allows catching multiple exceptions, and will run each block with those exceptions matching the type. Said again, instead of something simply returning or raising either a value error or type error, we have the possibility of raising value error and type error. Or value error and value error, or any number of the two. Mix and match to your heart's content. Your broken code can now error out in so many ways. Isn't that great? This brings us back to the title of the talk, how can one line of code have multiple errors? Technically, it can't. There's no raise star syntax added, which would allow us to raise multiple exceptions at once, because the designers of PEP 654 came up with a better way. ExceptionGroups. ExceptionGroup is a standard library exception added to the big tree of built-in exceptions in 3.11. You can find it in Python docs right here. I think they're fairly simple to understand. They comprise a string message and a sequence of one or more exceptions. The arguments are validated. Message must be a string, and exceptions must not be empty or contain non-exception objects. And it must be a sequence, no generators, dicts, or sets allowed. If you're not running Python 3.11, or you have a library that supports running on older Python versions, I have good news. There's an exception group backport package in PyPI, which provides an equivalent exception group class, though you cannot use the ExceptStar syntax in older Python versions. Just as an FYI, there is syntax for including package dependencies only if your Python version meets given criteria. Here's the magic incantations for a few standard options. Now that we have access to exception group, let's use it. Our something code will just be raising an exception group containing a not very helpful message. Then, the list of sub-expressions with value error and type error. Here we are dealing with both a bad value and something that should have been an int. Typically, this list would be built dynamically, but this is all slideware. First, let's check out the behavior of not catching anything. Let's call it and see what happens. Neat. It's a little unclear because I'm using Jupyter Notebook for this example, but here's our traceback to where the exception is being called in the other cell. Then we get this little ASCII art diagram of the contained exceptions, ordered by their index in the exception group's sub-exception list. Let's see what happens when we try to catch it. Huh, we get the same thing. That's weird. Oh no, it isn't. I forgot the stars after except. This is a standard try except, so it'll treat the exception group as a standard exception, and no blocks match it, so it raises up. Let's add the stars. That's better. And run it. That's not very informative. Instead of just printing E, let's print its repr. There we go. You see, the E variables are not the error type specified, but new exception groups containing the errors which matched that type. What happens if we don't match all the exceptions in the group? Let's leave only the except type error, and we see that it is handled appropriately, and the value error gets raised as before, wrapped in exception group. Just like normal excepts, we can include multiple types in one except block. Note that type error is used twice, and when we run this, we see only the first block matched. Exceptions are effectively taken out of the parent exception group as they're matched, so exceptions will only be matched once. How does except handle throwing a non-exception group exception? Let's just raise a value error. The exception is wrapped in a new exception group with no message. This is good, as the alternative would mean the type of E is dependent on whether the function raised a value error or an exception group containing a value error, and the whole point of except is to simplify that ambiguity. We have a guarantee that except always binds variables to exception groups, sparing us from collecting and re-raising exceptions from exception group oblivious code. But if we don't catch the value error, the except block doesn't change the raised exception to be an exception group, which would cause a lot of confusion. Next, let's look at what happens when you put an exception group inside another exception group. I'll let you imagine the code which does the real validation of our x and y values, but let's say it finds some errors, and we're using exception groups to report those errors. Now we have nested exception groups. So what does this look like? We get further nesting of our little ASCII boxes. I really like this. Let's use except stars. The formatting here is a little unfortunate, but here's a little sketch to help. The full tree of exceptions is walked, and any exception matching the subtypes are extracted into exception groups, preserving the structure of the original tree. What if we try to match all exception groups? Type error. We're not allowed to except an exception group. I guess that would be too ambiguous as to whether it's the raised exception group or an exception group within an exception group. Before you go and rewrite all your validation code, I want you to think about whether or not this output is useful. I think in most cases like this, we care more about the errors per value rather than grouping the errors by type. And if we're not grouping by type, then maybe simpler solutions should be used, like dictionaries or bespoke exception classes. I'd like to caution you against subclassing exception group because, as I've stated, those have the restriction that you can't catch them with except and that might surprise some of your users. Except for that box drawing stuff, that's great. You should find a way to hook into those routines for doing error reporting.
This isn't a complete guide. Exception groups have other methods, but I'm not going to cover them today. So when do we actually use these features? I'd say pretty rarely. Typically, good code won't fail with multiple errors simultaneously. That might be a sign you're doing too much in one function. The PEP lists 5 cases where exception groups are intended to be used: concurrency, retries, callbacks, wrapping code. By complex calculations, they mean things like backtracking algorithms and parallel computations where many things could go wrong at the same time. All of these are functions calling other functions, user functions which may raise anything. In particular, concurrency. In async code, we often do have points where multiple things are happening simultaneously, and any number of any kind of error could be thrown while waiting for tasks to complete. You're most likely to experience a thrown exception group when using an asyncio task group. If any of these tasks, A, B, and C, fail before the event loop returns to the calling function, the task group must report all of them, and you can see an example of the exception group here. So there you have it. A new exception had to be created to indicate simultaneous errors, and new syntax introduced to handle those gracefully. It's probably not a tool that you need very often, but I hope that after this presentation you'll at least know what you're looking at when you come across an except star. Thanks for watching, and I hope you enjoy the rest of your special winter edition of PyOhio.